Okay, so in this video, we are briefly going to discuss what's called the triangle inequality theorem, right? And the triangle inequality theorem basically tells us what kind of triangles are indeed possible, right? So if we look at this triangle here, okay, this triangle pictured here off to the right, well, we see, based on the side lengths at least, it's obviously scaling. Okay, and if I go ahead and label this, theta 1, theta 2, theta 3, based on the angles, this is obviously an obtuse triangle. Okay, so we could say it's scalene obtuse or obtuse scalene, right? We don't know the exact numerical value for any of the angles. We don't know the exact numerical value for any of the sides. We can simply deduce, theta 1 is obviously greater than 90 degrees, which is how we know it's obtuse. And we can obviously assume that C is greater than B, and B is greater than A in length, right? So if we continue on, so we've got a conjecture here. If this triangle, let's say any triangle, but let's assume that it's this one, right? If any triangle has three sides A, B, and C, with C being the longest, then a triangle where A plus B is less than C is possible, right? So I give you some examples you can play around with here. If you're watching this at home and you happen to have a ruler, go ahead and try to do this. So let's say, A is 2, okay, B is 3, and C is 10. So for scale, let's say this is 10, right? Let's say 2 is about right here and 3 is here. So 2, 3. Right? So this would be a length of 2. This would be a length of 3. Okay, so if I go ahead and start drawing these, so if I say, here's my 10 centimeter line, right? This is C because we're told C is the longest side. Okay, A, let's say A is 2. Draw it about the same size as what I see there. Okay, and C is 3. Draw it slightly larger. Not C, B. What's the matter with me? B is 3. Okay, we immediately see that we have a problem. Okay, we immediately see that this triangle is not going to close. Okay, and what's more, if we take 2 and 3, 2 plus 3, and add them together, that equals 5. 5, which is in fact less than 10 here, right? The longest side. Okay, so that means this conjecture is just plain false. Okay, and we see that using our rudimentary little method of drawing this out. Okay, so what does this tell me? Right? Well, what this tells me is this implies, because we have a contradiction, right? This implies that A plus B should be greater than C. Okay, this is of course where A, B, C are all greater than 0. This also is assuming that C is the longest side. A and B doesn't matter. We're not really concerned with the length of A and B. Okay, but what this means is what we call the triangle inequality theorem. Okay, so if I come back and reword this, and I take this away, and I say A plus B is greater than C. So if A plus B, right, is greater than C, and actually, I'm not even going to word it that way. I'm not even going to use like super special. The triangle inequality theorem is simply this. Okay, it's simply this. If a triangle has sides A, B, and C, with C the longest, then A plus B must be greater than C. Okay? And in plain English, what this tells us is no one side of a triangle can be longer than the other two combined. Okay? So the triangle inequality theorem in the teenager-friendly sense is simply that no one side of a triangle can be longer than the other two combined, right? Otherwise, that triangle looks like this nonsense that we drew here. Okay, so that does it for the triangle inequality theorem. If you have any questions over it, obviously you know where to find me or shoot me an email. Goodbye.